Da 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 da. I actually asked around for a cowboy hat. It turns out you have to have the right kind of cowboy hat, which was very frustrating. Let's do another review video. This one's a different way of organizing it. Most people like the map. For some people, this is what works. I call it the grid method. We're going to start with our first block in the grid, which is our basic hypothesis test. We're testing mu. We do know sigma. And so we can make a z-score because we have that sigma. And if you reorder this solving for mu, you get the confidence interval. These are the same equation. Make sure that you're comfortable with that. After that, we talked about what to do if sigma is unknown, which means our z switches to a t, and we use the s in place of sigma. The benefit of the grid method is you can see how these equations match up and line up. And if you get that, then the whole class becomes easy because there's really only one equation that we've worked with. Next, we talked about matched pairs. And for that, it goes back to just being a mu. Even though there's two mu's that you talk about in the question, the mu of the differences is what we want to test. And so we get the same equation here. We use 0 specifically because we're testing two different means against each other. And we put the little d on there just to remind ourselves that you're looking at the differences. But this guy looks an awful lot like that guy. After that, we've got what some students say is the hardest test, arguably. It really shouldn't be that bad. You should be yawning with boredom because, oh my goodness, how long do I have to sit and watch a video? Look, I'm pausing the video for like 5 minutes while I write all this out, okay? So you can sit and watch the video. We're doing two means, and they are independent. There's no matching going on here. And so we have two x bars, and here we have two errors. We square them into variances, add them and square root them, and our confidence interval follows the same format. The x bars, the t-score, and the standard deviations over the square root of n for each combined. After that, we talked about how to handle categorical data. Completely new and completely different. No, actually, the pattern still follows the same. We're testing the proportion, and so we get our z-score. Instead of x bar, it's a p hat. So we changed our notation. But once you think about it being ones and zeros, it actually comes out to be the same thing. This turns out to have a simpler form rather than recalculating your standard deviation. And our confidence interval is the same. Now, this is where the confidence interval does have a slight change. We have p's here and p hats there, but otherwise, this is following the same pattern. And I wish I could just scroll this up and do the last one, which would be a two-sample proportions. I realize I'm going to have to erase the board. Good news is you can back up the video if you need. But before I erase things, I also want to talk about the assumptions that you need for each of these tests. Because every one of these has got the same requirements. It either needs to say it's normal or have more than 30 data points. Normal or more than 30. Normal or more than 30. Now, if we're talking about two samples, then you need normality for each of those two samples or more than 30 in both of them. Either one of them doesn't have 30, you're stuck. This, however, for proportions, does have a slightly different rule. You see, for these guys, it can be either normal or more than 30. It doesn't have to be both. If it's both, then I guess you're double covered. But if it says it's normal and you're less than 30, you're okay. If it says it's not normal and you're over 30, you're okay. But for proportions, you really need both requirements. NP greater than 15 and N1 minus P greater than 15. And if you have P hat instead of P, then use the best thing you've got. But both of those need to be true. This is how many said yes. This is how many said no. That's what has to be more than 15 in both cases. Now, I wish that I could just scroll the board up, but I can't. I think I'm going to erase these middle three and move this guy up like this. And now we are ready for the last one that we've talked about, which is that two-sample proportions test. And we're testing our two means. We've still got our x bar, which is now two different x bars, and we're in categories. So this is two different proportions. Minus the 0 for the same reason we had before. I wish I could just point to it because I had to erase it to make room. But we've got our p1 minus p over n, p1 minus p over n. Now for the hypothesis test, this is p bar, that pooled proportion. For the confidence interval, we use the p hats. So confidence interval, you could argue, is actually a little simpler. How do you get that p bar? You take the yeses from group 1 and the yeses from group 2. You can write that as NP, that's the number that said yes. You could write it as y. The problem is then you look at the ends and you think that's no's. It's not. It's the number. So welcome to confusing letters in statistics. But how many said yes? out of all the total, regardless of what group they were in. That's your pooled proportion. It goes in all four of those places. And I hope at the end of this that you see the pattern, how it's all the same, and that if you forgot something on your study sheet during the exam, you could say, okay, I'll bet I can figure out what it is I'm missing.